Hello everybody, how are you? Happy Pi Day! Or if you're in another part of the world, happy Pi plus 0.01 day. Well, it happens to be one of these special days, March 14th. For those of us who write the date as month first and then day, then that would be 3/14. For the people who write it as day first and then month, you're wondering, what are you guys all talking about, this 14/3? I mean, what's that? Happy 4.66666 day? Not really sure what that's about. But in any case, we're going to have some fun today because we're working on MATHCOUNTS problems. So MATHCOUNTS is one of these wonderful competitions in the United States of America. It's for middle school students, although the questions are often quite challenging. And we're very happy to be doing an official collaboration today with the MATHCOUNTS competition. And we'll do some of these questions in the chapter invitational round. We started and we did the first 20 questions yesterday, and today we're just going to continue on from where we left off. As you know, last time what we talked about was we talked about how to do various questions. We saw some neat coincidences, like a math fact, which I now think is really nifty. 2 times 3 times 5 times 7 times 11, product of the first 5 primes, is just like 2310 or something like that. Really neat number. We also learned how to sleep in airports. But now let's go and do some more problems. So this is where we left off. We left off with the answer to everything, 42. And the next question for today happens to be question number 21. What's this about? Let me zoom in so that I can read the screen better. Triangle ABC has sides of length 11 inches, 15 inches, and 16 inches. What is the length of the altitude to the side of length 15 inches? Okay. So let's go ahead and try to draw this altitude to the side of length 15. That makes me want to make the 15 into a base. Excuse me. Maybe let me take a drink of water. Then that'll help me a lot. When in doubt, drink water. And today we'll also do some pie eating later. So we have 15 on the base. We have sides of length 11, 15, and 16. So I guess that's... Excuse me. So it's something like this. 11, 15, and 16. At first I look at this and I say, oh no, I don't know any Pythagorean triples with 11 as the hypotenuse. Don't worry, I'm not sick. It was just something to do with water. Some water got in my throat. But let's continue. So it's like, oh no, I can't actually use any nice Pythagorean theorem. The questions are getting harder. So what I'm going to do here is I'm going to say, I want to know the altitude to the side. So I really want to know, what is this height? Gee, that's interesting. So I know that there's a 15 and there's an h. I know an area formula. A formula for the area of the triangle is equal to 1/2 times the base times the height. Gee, if I could find any other way to get the area of the triangle, I'd be very happy. But yes, Heron's formula, that should be what we do. We should go and use the Heron's formula because I've got 3 sides of the triangle. And Heron's formula tells you that the area, actually the proof of this is really neat, but that's a proper lesson. I mean, if I was teaching you, I'd go and show you the whole proof, but we're just doing the problems here. The area happens to follow a certain formula, where S, there's something called S. S stands for the semi-perimeter. The semi-perimeter is half the perimeter, 11 plus 15 plus 16 divided by 2. And the area is the square root of S, S minus A, S minus B, these are the side lengths, and S minus C. Okay, so I just need to work out all of these things. Let's go! Alright, so 11 plus 15, that is 26. 26 and 16, here's actually how I'm going to do it. 26 plus 16, that's like, not 42, but, oh, it is 42. Wait, really? 26 plus 16 is this wonderful number? I can actually believe that. I was afraid of whether I got the tens digit wrong, because I'm always afraid of carrying the wrong way. But the way I double checked that is I was like, it should be around 3 times the average, and the average is around 15-ish, a little bit less, and so 3 times 15 is 45, therefore 42 does make sense. Neat! Okay, 42 divided by 2, that happens to be 21. Okay, now we just go ahead and fill all of this in. So if that's going to be the area, let's continue. So that's equal to square root of 21 times 21 minus 11 is 10, times 21 minus 15 is 6, times 21 minus 16 is 5. This is making me quite happy because when I look at this, I see that a lot of common factors are here. For example, the 5 is going to match with the 5 there. That's a 5 times 2. And the 6 has a 3. The 3 is going to match with the 3 from the 21. So let's continue this and do it in factors. This is 7 times 3 times 2 times 5 times 2 times 3 times 5. And now let's look at the places where I have the same factor twice. I have 5 twice, I have 2 twice, and I have 3 twice. So if I figure out what that is equal to, then every time I have something twice, then that thing pulls out, okay? So what I have here is 2 times 3 times 5, square root of 7. And that is don't first multiply things out. See what we want to cancel. So we know that 2 times 3 times 5 times the square root of 7, that's the area. That's what Heron's formula said. And now what I want to do is I want to match that against this because I'll get an equation with h. So that's equal to 1/2 times 15 times h. Wonderful. I see that the 15 cancels with this. The 3 times 5 is 15. So now I just go and simplify. H is going to be times 2 on both sides. H is just going to be 4 root 7. Okay. I also want to just double check. Does that make sense? So what is root 7? Because whenever you do these things, you might be off by a factor of 2 sometimes. So I look at root 7 and I say, well, the square root of 7 is between 2 and 3. Because square root of 4 is 2 and the square root of 9 is 3. So it's actually probably around 2.5-ish. And actually I know that because 2.5 squared is 6.25. So it's a bit more than 2.5. So 4 times 2.5, that would be about 10. Does that seem right? Yeah, that seems right. It shouldn't be as big as 11 because actually this 11 is the hypotenuse, so it has to be less than 11. So I pretty much believe this now, and the diagram looks sort of to scale too. So I'm going to say the answer is 4 root 7. Okay, so 4 root 7 is the answer I'll put. Let's put a box around there. And let's see if this is the right answer. Good, it is. Next question. Actually, I just realized I should make sure my microphone isn't too loud. Oh, good. Okay. I have a microphone recording all of this, and I want to make sure I'm not going too loud. I'm looking at my volume meter, and it seems to be going to the maximum. But hopefully that just means you guys can hear me. Okay, next question. Question number 22. Julie is packing marbles into boxes. She needs to pack away 815 marbles. She has boxes that can hold 10, 25, 50, or 100 marbles. If Julie can use at most 5 boxes of each size and must fill each box she uses, what is the minimum number of boxes she needs to pack all her marbles? Don't lose your marbles. Okay. So when I look at this, I will usually want to use the greedy algorithm first. I need to use at most 5 boxes of each size. So let's go and take the biggest ones first because I want the fewest boxes and see if I need to do any finesse at the end. Okay? So 5 boxes maximum of each size. Let's go and grab the 100 things with 5. Suppose I did that. That's going to leave how many left? 315 left. Okay, the next thing is, I guess, let's try to use the 50s, see what happens. Grab 5 of them. Grab 5 of them. So that would take 250 out, and if I take 250 out of this, that's going to give me 65 left. I just subtracted 315 minus 250 in my head. And the next thing is now I have 25s and 10s. Well, I don't want to take too many 25s. And already I see that now there are a few things I can mess around with. I see that there's a 65, right? So since it's a 65, I need to use only one 25, not 2 of them. Because if I tried to use 2 of the 25s, that would be no good. I would end with a 0. And so with this thing, there's 40 left. And then finally, I guess I take 4 10s. Okay, 0 left. And now the only question is, can I do any better? if I wanted to do better, the only thing I could try to do better is to maybe take more of these 25s, because we always want to compare and see if we can do a better job, right? So, well, if I look at what was giving me the trouble was this 815. So with this 815, no matter what, yeah, I think I'm stuck. Because you see, if I take any of these other things, if I tried to, for example, substitute some of these things, take fewer of them and take more of the other things, that wouldn't do me any good, because all of these things are also multiples of 25. What I mean is, my big problem was I had to split something into a particle size that's smaller than 25. And unfortunately, I can't do that any smarter by taking less of those, because all that's going to do is make me need more 25s instead. So I'm okay. Basically, the only reason I couldn't take two 25s is because of this last digit being a 5. So that's why I got stuck. And so I have no other way than to do this. Therefore, the answer I'm going to put is 5 plus 5 plus, well, that's another 5. That's 15. Let's see if this works. Okay, let's see. What do we have here? It is. Next question. 23. What positive number x has the property that, and it's hard to make these slides look quite right, so I'm going to go and draw some extra things. I think these are supposed to be roots, okay? So I have the 6th root of x to the 7 minus 6 times the cube root of x squared is equal to 0. Well, when I look at that, the way I think of it is I say, well, I see a 6th root and I see a cube root. Those make me happy because a cube root is just the square of the 6th root. So what if I just say y? Let y equal the 6th root of x, okay? This is nice because now I'm going to get a quadratic type equation, right? Because if I do that, you know what's y squared? Y squared is when you ask too many questions. Why? Why? No, that was stupid. Anyway, so this is the cube root of x. It's the cube root of x because actually, the way you should think of this is with these roots. If you're ever wondering which way this goes, the roots, by the way, the roots are like fractional powers. The reason it's a fractional power is because if you had a 1/6 of an x, if you could have such a thing multiplied together, then you put 6 of them together, multiply 6 of them together, you get like a whole x multiplied together. That's the general way that this product of exponents works. And so over here, this is cube root of x, this is x to the 1/3. And as you can see, when I square the x to the 1/6, then I get x to the 2/6, which is x to the 1/3. Okay. So now we've got this thing, that we've got these y's. Now let's go and make the actual equation. Now I have that y to the, yikes, really? Okay, y to the power 7. I didn't see those other powers inside. Let's see what happens. Y to the 7 minus 6 times y squared is equal to 0. That's my equation that I've got here, okay? I've got y to the 7. Do I really like that? I guess so. Okay, it's making me scared because I'm going to get some weird things soon. Trying to read the question to make sure I'm right. Okay, because if I have the 6th root of x, then the 6th root of x to the power 7, that's going to be x to the power 7 over 6, actually. This is x to the power 2/3. Let's keep trying, because I'm wondering why the question didn't say simplest radical form. Now, if I see this thing, I can now continue to work on this, and I'll get y squared. I'll factor it. Y to the power 5 minus 6 is equal to 0. Okay, so this is actually kind of odd. So if I have this thing, if I look at this, how can I make this thing to be equal to 0? Well, either that's 0 or that's 0. And one way to make this 0 is just to have y equals 0. But if y equals 0, then x equals 0. 0 is not a positive number in the United States. I think there are some countries where, I think it might be French, where positive includes 0. I'm not entirely sure. I don't know French. But this is not French. So 0 is not okay. If I go over here, then this guy is going to give me 0 exactly when y is equal to the 5th root of 6. Okay, that would work. And then now I just have to go and say, well, if that was y, if y was the 5th root of 6, what is x? X is equal to y to the 6th power. So this is weird. Usually the problems don't look this messy, because this would give me that x is equal to the fifth root of 6 to the power 6. Something's fishy. I don't like this. So I think that there might be some kind of a... Oh, somebody's telling me that there is a typo in the problem. Is there a typo in the problem? Okay. Evan John says it should be y to the 7 minus 6y to the 4. Oh, because I got it wrong. Okay, thank you, everyone. So I actually got it wrong. I got it wrong. The reason I got it wrong is because I didn't look at this carefully. Wait a second. Is that right? Yeah, because if I have the cube root, yeah, I got it wrong. Okay, so I was going to say this, and I was like, that is just totally bogus. And I would have gotten this one wrong. Except that, thank you, there are smart people watching this live stream. And the smart people watching this live stream said, you know, you made a mistake here. If I have x to the power 2/3, that's not y squared, right? Over there, I made a mistake. Yeah, thank you, guys. So this was supposed to be x to the power 2/3. What kind of arrow is that? The arrow is supposed to go here, okay? This is x to the power 2/3. And x to the 2/3 is actually x to the power 4 over 6. And remember, 1/6 power, that was the y. So in fact, this should be a 4. Oh, nice. So this thing is a 4. I'm just going to use a different color so that everyone knows that was a mistake. I made a mistake, but thankfully people are here fixing it, okay? So that's supposed to be a 4. And if that's a 4, now life is better. Because now this guy, I factor out a 4. And now I get something proper. This is giving me y cubed minus 6. Okay? Why I said it's giving me something proper is because the question didn't say show the answer in simplest radical form. So I got very suspicious. So over here, now I would find out that y is the cube root of 6. Much, much better. Now if y is the cube root of 6, I just need the 6th power that. And so the x would be, if I want to have the cube root of 6 to the 6th power, the cube root of 6 is 6 to the power 1/3, raised to the 6th power, that's 6 squared, which is it's a whole number, 36. Okay, so we'll go with 36. Let's see if this is right. And as you know, I would have gotten the question wrong. But thankfully, I'm doing the question on YouTube Live, where I have lots of people to go and help me. And it is! Good job, guys. Good job, guys. I was like really confused. Like, what in the world happened there? Because you're not supposed to get weird numbers. Thank you, everyone. Okay, next question. 24. What fraction is equivalent to... I can't exactly tell. I can't exactly tell which digits are repeating. I think it is 0.7 and 1,2 are repeating. Does anyone know what the question's supposed to be? Is the question supposed to be 0.712 with the 1,2 repeating? 1,2. Okay, people say it's 1,2, 1,2, 1,2. Okay, 1 and the 2 repeating. Let's do this now. So whenever I see a question like this, here's what I do. I go and say, I know what's 0.12 repeating. 0.12 repeating is beautiful. That actually is just 12 over 99. Okay, this is a standard math counts type thing you do, but if you want to know why that's true, you can just go and say, if I had 0.12 and I multiplied it by 100, right, just a quick review of like why that's true. If I took this 0.12 and I didn't know what it was, x is this, and I took 100 of it, then I just get a 12.12 repeating, which then if you subtract, you'd get 99x is equal to 12. Okay, this is just a really quick review of why this thing is true. That horizontal line doesn't look like it's in the right place. Something like that. Okay, great. So that's this 0.12 repeating. Now if I want to know what happens when I kind of shove over the 0.12 by an extra place, well then I'll call it 0.0 and then the 1,2 repeating but not the O repeating. That's equal to 12 over 990. Now, how do I get an extra 0.7? Well, let's just add 7/10. That will do it. 7/12. This is how I always do these problems. This is going to be 7/10 plus 12 over 990. And I know there are other ways to do these problems. In fact, one way to do this problem would have been just to take this guy, multiply it by 100, and do something similar to what we saw here. Both ways are fine. Somehow I just always do it this way. I don't know. The other one, you know what? The other one might even be more efficient now that I think of it. Oh well, I often do it this way. Well, let's do it the other way for fun in a second, to double check, okay? So then this thing is equal to, what is this? It's over 990. Yeah, maybe this is not as nice. Let's compare to the other way in a moment. I need to do 7 times 99. To do 7 times 99, that's like 7 times 100. 700. Just kidding. Subtract 7 because it's 7 times 99. So it's 693. Right? What I just did is I took 7 times 90. I wanted over 990. So I did 7 times 99, which is like 7 times 100. Just kidding. Minus 7. So I'm here. Also, this is satisfying because the multiply by 11 trick, this is telling me this is 63 times 11. Remember, we did that earlier in this math count set, where if you multiply a number by 11, you just write the 2 digits there, and you put the sum in the middle. Okay, plus 12. And the answer to this is, what? So 3 plus 2 is 5, 9 plus 1 is 10, 705 over 990. Ooh, this is tricky. But if we want to do a simplest form, I see that there's some divisibility issues. Because 705, that's actually a multiple of... Right, 705 is a multiple of 3, because the sum of the digits happens to be 12. 12 is a multiple of 3. So I can divide through by 3, 330 on the bottom. 3 times 2 is 6, 3 times 3 is 9, 3 times 5 is 15. Oh my gosh, we get to do more canceling. So more canceling, because there's this 5, right? Factor of 5. So divide out the 5. Oh, you know how you divide 330 by 5? You divide it by 10, and you times 2. So that's 66. 235 divided by 5. 5 times 4 is 20. Okay, then there's 35. 5 times 7 is 35. 47 over 66. Now, 47 over 66, 47 is a prime number, so I'm not going to be able to get any further. So I think the answer to this whole thing is 47 over 66. Now what I'm going to do is I'm going to do it the other way just to compare notes. All right? So let's do this 0.712 again. And if I wanted to do it again, I could say, all right, x is equal to 0.712 repeating. Okay? Actually, I often like patterns. I'm just going to do a bunch of them. ... That's what we've got here. Now let's do 100x. If I do 100x, I get 71.12. Is that right? No. 71.21. 2. Perfect. Now if I subtract, a big canceling happens. Subtract, I get 99x's equals 71. Oh, what is this? No. When you subtract, you have to borrow. 70.5. Right? Because I just did the subtraction upside down. 12 minus 7 is 5. Borrow, I get 70. So I found out that x is equal to 70.5 divided by 99. Now, even if you forgot that you were supposed to cancel out common factors, you would know that this is not a very good fraction. This is a very lousy fraction because it has a decimal on top. But I'm already happy because it's matching the form we had before. Actually, now it looks like this is more efficient. Just comparing like what I was doing the first time, doing this way, it's actually maybe worse. So I think I've learned something today, which is that this method is not actually very efficient. But the other way, I can do this and right away get 705 over 990. All right. I see that there are other methods too. Of course, feel free to type in the chat if you want. It's fun to have so many people here thinking about these questions. But now our answer was something over 66. 47 over 66. Compare. It is. Okay. Question number 25. Oh, geometry time. In the figure, 2 circles of radius 1 inch are internally tangent to a circle of radius 5 inches so that the centers of all 3 circles are collinear. Ooh, so they are. All 3 circles? Really? I'm looking at this. 2 circles of 1 inch are internally tangent of a circle of 5 inches. Okay. Oh, yes, of course. Because I was like, what's up with this thing? No. The 3 circles are this one, and the circle with 5 inches diameter. Okay. Those centers are all on one line. I'm okay with that. Next, a 4th circle comes in here, tangent to all 3 of them. What's the radius of the shaded circle? Oh my gosh. Okay, and it's a common fraction, so I shouldn't have any square roots here. Well, if I look at this, whenever I see circles, I just go and say, let's start to draw lines that go between the centers of circles, because those behave very well when I think about tangents. So I'm going to go and draw the center of this circle. I think that looks like the center. Maybe a bit high. That looks like a center. Okay. I drew that one on purpose because if I go and take this line, look at that. It just goes right through that, and they go right through the tangency point. That means that this part is a 1, and this part is the unknown radius, r, which I need to solve for. What else might I know? Well, I see a right triangle materializing. This and this. This is a really nifty problem. Okay, what's this? Well, I know the radius of the big circle is 5. That's the center of the big circle. And what's this? Well, if I went all the way, I'd get 5. But I don't go all the way. And since I don't go all the way, I subtract 1, right? That's how much is missing. So it would have been 5 if I went all the way across. But I don't go all the way across. I subtract 1. Therefore, this is 4. I'm trying to write this in a way where we can see the length. Let's do it like this. This whole thing is 4. Okay? And now, if only I knew that. Well, we can use that same thing again. If I went all the way up, that would be 5. And that much is r. So since this much is r, then what's left over is 5 minus r. Aha! It looks like it's time for the Pythagorean theorem. I have a 5 minus r, I have a 4, and I have an r. And they are supposed to satisfy the Pythagorean theorem. Now let's go and do it. The Pythagorean theorem tells me if I took 5 minus r squared plus 4 squared, that's supposed to be equal to r squared. I guess I just need to solve that now. I can see that these questions are already getting harder. If you compare these to the ones we did at the very beginning last time, these require like serious algebra or geometry understanding. I see somebody is already saying to use FOIL for 5 minus r squared. Also use FOIL whenever you are baking a pie. So, okay, let's do this. Actually, whenever you do these things, it's a nice pattern. If I ever have like an A, well, okay, it says minus here, so I'll put the minus. A minus B, although this also works with pluses and like multiplying, okay? So if I have this thing when you use the FOIL, you get like A squared, that's the two first things, and then the outer becomes minus AB, the inner becomes minus BA, the last is plus B squared, and this is a nice pattern that you see a lot, A squared minus 2AB plus B squared. And I will just go and throw that in right now. So what we have here is this is 25 minus 10r plus r squared plus 16 is equal to r squared. And that makes me happy, because whenever I have squares, I'm worried that there's going to be square roots. And it said express the answer as a common fraction. And the way I know that's not going to happen is because the r squareds cancel each other out. So now it's going to be a nice fraction. Add the 10r to both sides, you get this, equals the left side 25 plus 16 is 41. Okay, so r is equal to 41 over 10. And I think that's the answer. Let's go and see if this is correct. Okay. Uh-oh, some people are saying it's not something. Maybe it's wrong. We'll find out soon. Oh no, it's wrong. We made a mistake. Okay, thanks guys. Just over there I saw that there's some chat. We made a mistake. Oh no, what's the mistake? Let's see. So this was supposed to be 5. 5 minus r. That's okay. Oh no! It's r plus 1! It's r plus 1! Ouch! Ouch! No, this is the second mistake. These questions are getting harder. So, it's not r. It's r plus 1. 2 mistakes. Yes, that's right. This is supposed to be r plus 1 squared. Okay? So if that's r plus 1 squared, then it becomes more messy. Then over here, we're going to get r squared plus 2r plus 1. Okay. Now when I go and look at this, these cancel. Okay. And now those two cancel. And now I have to go and see what's over here. I'll have a 10r plus a 2r. That makes 12r. So we're here at 12r. And now on the other side, I have to go and subtract an extra 1. That's going to make 40. You can see how I'm changing everything as I go. So now what I find out is that r is going to be 40 divided by 12. which this one you actually have to simplify. Let's go and divide through by 4 on the top and the bottom. Divide through a 4 on the top and bottom, you get 10 and you get 3. And so now we get the answer of 10 divided by 3. Okay, so that's actually what we have here. Wow. Express answer as common fraction. So is that right? Yes, that's right. Actually, what you're seeing here is that this is why checking is very important. So whenever you do a problem, make sure, I guess, if you have extra time at the end, it's very, very good if you can run back around and look at the questions that you've already done. Or if you don't have extra time at the end, I guess one thing that we need to learn is whenever we write something down, take a second look at it to make sure it's right. Okay, let's keep going. Question 26. What's this? The greatest of three non-negative, let's see. The greatest of 3 non-negative integers is 1 more than twice the sum of the other 2 integers. The arithmetic mean of the 3 integers, rounded to the nearest integer, happens to equal the median of the set. What is the product of the 3 integers? Whoa! Okay, so I've got 3 numbers here, all right? And I'm trying to go and figure out what I can do to try to solve this problem. I have these 3 numbers, and I've got the biggest one is 1 more than twice the sum of the other 2. So I guess I've got some numbers, and the numbers happen to be in order x, y, and 1 more than twice the sum of the other 2. That's 2x plus 2y plus 1. Okay, so these are my 3 numbers. And let's assume they're already in order. So that's the smallest, middle, and biggest. I know this is the biggest because I'm adding stuff together, and they're all non-negative. Okay? Next, I know that the arithmetic mean of the integers, rounded to the nearest integer, happens to equal the median. What's the arithmetic mean? This is making me happy, because if I add these together, something neat happens. Arithmetic mean is just the average. So the average is the sum of all of these divided by 3. There are 3 x's altogether, 3 y's altogether, and there's an extra 1 divided by 3. That's equal to x plus y plus 1/3. Oh, look at that! Now, what does that mean if I round that to the nearest integer? If I round that to the nearest integer, x and y are integers. So this is an integer and a third. Well, if you round it to the nearest integer, you're just going to lose the 1/3, right? That's all that's going to happen. So when you round it, you get x plus y. Okay? And now supposedly, whoa. Okay, it's telling me that the x plus y happens to equal the median. I said that that's the median. Whoa, then I know something about x, don't I? Because if I know that x plus y is equal to y, then x better be 0. Oh, that's why the question asks what's the product of the 3 integers. This is so nice. Oh, you multiply by 0. Let's go and check, okay? So apparently, it's okay just to have x equals 0, choose any y you want, and it's going to work. Let's go and try. All right? So already what I've just found out, let me write down what I found out. It was that, hey, look, that's equal to x plus y. So x is equal to 0. And so multiplying them all together, you just get 0. All right? And now let's go and check. Does it actually work? Try. If I use 0, what's a good choice for y? 1, something really simple and small. That's a non-negative integer also. The greatest one is 1 more than twice the sum. The sum is 1, twice the sum is 2, 1 more than 2 is 3. Okay? And now if I have this, what's the arithmetic mean? That's 4 divided by 3, which is 1. Oh, that's equal to the median. Yeah, that's right. And therefore the product is 0. Oh, this is so neat. It's 0. Somebody just asked, does it matter if you let x be greater than y or y greater than x? Well, there's a difference if you want to say which one is the median. I actually wanted to say these are in order so that I can say the median is definitely that one over there. Because the median, you care about the order. So that's why I did it this way. But so my answer to the whole thing is just plain 0. Let's see if that's correct. It is 0. When I was doing math counts, somebody once gave me the advice that if you need to guess on a bunch of questions, just guess 0 or 1 for the answers. Because there might be one of these funny questions here where the answer is 0. Next, question 27. Suppose p of x is a polynomial. Middle school students have learned about polynomials? Wow, You guys are so smart these days. Okay, such that p of x equals p of 1 plus p of 2 times x plus x squared for all numbers x. What is the value of p of 5? Okay. Polynomial. Polynomial, by the way, if you've never seen the word polynomial, a polynomial means something that looks like, I'm just making up a random polynomial. This is not what it actually is, but it might be like, I don't know, a legit polynomial could be something like pi times x to the power of 5 minus 3x squared plus the square root of 2. That is a polynomial. Polynomial just means that it's a bunch of things where you take powers of x. The powers of x are whole numbers, and they're from x to the 0 all the way to x to the whatever. It's a sum of these, and you can throw any kind of nonsense you want in front of the x's. Nonsense meaning like nonsense numbers. Okay, that's a polynomial. Looks something like this. But now I need to say p of x happens to have some property. Okay, interesting. So I'm gonna block this out because that's not the actual polynomial. I'm just telling you the polynomial might look something like this. Now if it's supposed to be true like that for all numbers x, I wonder, ooh, I see what's going on here. Let's go and figure out what p of 1 and p of 2 are. Okay, if I could figure out what p of 1 and p of 2 are, then if I just throw 5 in, I'll just take whatever the p of 1 was, plus p of 2 times 5 plus 5 squared. How could I figure out what p of 1 and p of 2 are? I can substitute x equals 1 and x equals 2. Because whenever you have something telling me if this magic fact is true for all numbers x, well, let's try using it for some of them. For example, when x equals 1, the fact tells me that p of 1 is equal to p of 1 plus p of 2 times 1, that's just p of 2, plus 1. How nice. Cancel. So I've just found out what is p of 2. Okay? And importantly here, the way you should think of this is a polynomial is really just, it's a function. I guess you guys do definitely learn that in algebra class. A function means I can throw anything I want in it. There's these function machines. And so what I did is I just threw x equals 1 in. I got an equation, and I found out that then p of 2, that's negative 1. So this is powerful. Next, let's go and shove in x equals 2 into this nice fact that I get to play with. Now, p of 2, because the nice fact says plug in x equals whatever and the rest holds, p of 2 is equal to p of 1 plus p of 2 times 2, I'm going to call that 2 times p of 2, and then plus 2 squared, that's 4. But I know what p of 2 is. It was negative 1. So that means negative 1 is equal to p of 1 minus 2 plus 4. P of 2 was negative 1, so this is okay. So then I know p of 1 is, let's go and move everything over there. So on the right side, I would get a normal 2. Subtracting 2 from both sides, I get minus 3 is p of 1. Okay, so now I have some interesting fact. I now know that p of 1 is negative 3, and p of 2 is negative 1. So now let's just go and do this. Plug in x equals 5. Now the unknown thing is here. I don't know what this is, p of 5. Well, that's equal to p of 1 plus 5 times p of 2, because that's p of 2 times 5, plus 5 squared, which is 25. And now I use the fact that I know p of 1 and I know p of 2. P of 1 is negative 3. P of 2 is negative 1. Add 25. Okay, and so the way I like to do this is I like to subtract the 5 from the 25. I have 20 left, and I subtract 3 from 20, and I get 17. Okay, I think that's the answer. And this is a neat question because I like this one because it's not clear what you should do at the beginning. So you go and mess around and you try stuff. And for me, whenever somebody tells me something is true for all numbers x, my knee-jerk reaction is, let me go and stuff some x's in. What would I want to put in? Actually, I can find something else that's cool. You know what's p of 0? What happens if I throw in p of 0? It's the same as p of 1. That's neat. P of 0 is equal to p of 1 plus 0. So that's kind of neat. But that wouldn't have been useful because nobody asked me for P of 0. So the way I worked backwards to solve this was I was like, I need to know P of 5. Okay, I'm going to throw 5 in. If I throw 5 in, I wish I knew P of 1 and P of 2. So maybe we can work that out by substituting in x equals 1 and x equals 2. In theory, you would be able to, because if I did that, I'm trying to figure out what is P of 1 and figure out what is P of 2. These are like unknowns. And I would have 2 unknowns and 2 equations, which you could actually solve. Okay, let's see. Is the answer 17? It is. Next question. Question 28. Let the floor of n, that's the symbol for floor, it's like you round things down, be defined as the greatest integer less than or equal to n. What is the value of n if the floor of n times n is equal to 3? Express your answer as a decimal to the nearest tenth. Okay, so I have to be multiplying something where I rounded it down and then multiply it by itself, I get 3. Well, the important thing is if you round something down, it's going to be an integer. So let's start to like puzzle through this, right? Could the floor of n be 2? Well, if that was the case, if the floor of n was supposed to be 2, then I would need to know that 2 times n is 3. Okay, then 2 times n is equal to 3. Hey, I can solve for n. Then n is equal to 3 over 2, which is 1.5. No. The floor of n is not 2, because the floor of 1.5, rounding it down, gives you 1. So no. Floor of n cannot be 2. I was just kind of curious. And if the floor of n was 1, would that work? You can see how this is working. If the floor of n was 1, then n is equal to 3. You round that down? No, that's just 3. So I'm just going to work to the next one. Could floor of n be 3? And if I found myself not making much progress, I might skip ahead and try to do something called binary search. I might try to go and it's like how you guess a number. If somebody has a number in their head, you go and say, hey, is it 50? And they tell you if it's bigger or smaller, this kind of thing. But I have an instinct that we're getting close. Because if I do n equals, if the floor of n was 3, wait, what in the world am I doing? Is this actually going to work? No, that's not going to work. I'm going the wrong way. Wait a second. Ooh. Oh my gosh. This is tricky. I wonder if negative numbers are going to come into play. Because if I do this, floor of n equals 3, well, that'll give me 3 times n equals 3. No, that's worse. N equals 1, you round it down, it's not going to work. In fact, I'm getting smaller. It's like they're getting farther apart, right? Because over here, if I'm taking the 2 and I get 1.5, rounding it down is not 2, but rounding that thing down is really not 3. Something makes me want to go and check. How about could the floor of n equals 1? Well, then that would give me 1 times n is equal to 3, and that gives me n is equal to 3. So I basically crossed over already from an issue where somehow over there, it's like, well, if I round that down, it's too big. But now I round that down, it's too small. Round that down is way too small. It's negative numbers time. So now I go and say, oh, there are ways to get the floor to be like -2. Something tells me this feels like a sweet spot, okay? Could the floor of n be -2? Now, if you round something down and you get -2, it's -1 point something, okay? And that's making me happy because then I know that -2, that's the floor of n, multiplied by n is 3, n is equal to -1.5. Oh, look at that. If I take -1.5 and I round that down, I get -2. This is tricky. And so what I found out is that actually works. N equals -1.5, round it down, you get -2, and times -1.5 is actually 3. 2 negatives make a positive. So I found out that the answer is -1.5. Don't forget to go and check the negative things, okay? Whenever you do these kinds of problems. Let's see if that's right, first of all. Tricky. This is a very tricky problem. As you can tell, we're getting towards the end of these problems. Oh my gosh, what's next? Question 29. Better take a good drink of water. All right. Square ABCD, shown here, has side length 6 units. Points P and Q are located on sides AD and BC. Sure they are. I see. Okay. respectively, with AP and BQ equal to 1 unit. Okay, knee-jerk reaction, label the lengths. And now we also know, don't make the mistake of like forgetting to add stuff like I just did earlier. Okay, triangles ACP. Where's ACP? ACP. Oh yes, they do overlap in the square. They form this little shaded quadrilateral. Okay, that's true. Shaded quadrilateral. What is the area of the shaded quadrilateral? Oh, that's nifty. Wow. How do you do these questions? Okay, so if I see this, I'm like, I need to go and maybe cut apart the quadrilateral. Can I find something that I can do? Oh, yeah. Maybe. Okay, you got me thinking now. What I'm going to say is, I can see I can sort of cut apart the quadrilateral if I wanted to. And, I'm working out the lengths that I could make some sense out of, right? So, for example, if I cut here, I can tell you the length of that. Because there's like some nice fact about these two triangles. These two triangles happen to be, because of symmetry, the place where these are intersecting, this is right on the line of symmetry, which is halfway in the entire picture. And so since this is halfway in the entire picture, I actually know the length of this yellow this yellow line. Because there's a nice fact about triangles. If you ever went and drew, a triangle, any old triangle, and you cut it exactly at the half, guess what? That's half of that. That follows by something called similar triangles. So I could find that if I wanted to. Do I want to is the question. Okay. So I see. Okay, I'm going to do this in a way that might actually not be very efficient, but it will get the job done. Okay, so this looks like we're getting, and I'll be very interested to see other people's ways of solving this too. But so here's how I'm planning to do this. I know this length. That length is 1/2. The reason that length is 1/2 is because this length is 1, and this is halfway along on this triangle. Okay, so just because of this picture, this is like a similar triangles issue. I can figure that out. I know this length is 1/2. I can actually figure out the other length. If I figure out the other length, then I'm all done. Because if I figured out the other length, I can actually use an area formula. You see, if I manage to find that I have a kite, this is called a kite, and if you know the two diagonals of the kite, first of all, they're perpendicular. Do you know how to get the area of the kite? If I knew the two diagonals of the kite, I can actually find the area. In fact, the area is exactly the product of the diagonals divided by 2. And here's why. Look, let me go and draw what would happen if I actually legitimately multiplied the diagonals. If I multiplied the width and the height, yeah, I get the whole thing. I get this big old rectangle thing. And you see the kite is exactly half of that. Because these two are the same. These two are the same areas. Actually, they're also the same. They're congruent. Those are the same. So what I'm saying is that, like, look, the kite's area is going to be exactly half because this rectangle splits into 2 parts, that rectangle splits into 2, that splits into 2, that splits into 2. So that's why all I need is to multiply the 2 diagonals by each other. That gives me the whole thing, and then divide by 2. All right? So that's what I want. Now, I just need to know that other diagonal. And there's a way I know I can do this. It's called brute force. The reason I know I can do this by brute force is because I can think of these as coordinates. This is probably not the most efficient way to do it. I'm trying to think, because I'm pretty lazy. Lazy people like to find other ways to solve these problems. But even though I'm lazy, I see another solution that will get me done. I see that this will work. So I'm saying that, I could just think of the equations of some lines. Here's a line. And here's a line. If I just take those 2 lines, I can solve for that point. Once I found that point, I'm in business, because I will just go and look at the x coordinate of that point. So I know this is going to work. Okay, so let's go and do it. And why did I draw these? I drew these because I know the equation of this line. This is like the easiest line in the world. Here are my axes. So this is actually not an awful way of solving the problem. It's probably not the best. But if I do this, right, I have that and I have that. Right? And so if I look at these, what's the equation of the green line? If this is like the x-axis and that's the y-axis. I like the green line very much. The green line is just like the y equals x. It's just going straight up the diagonal. Okay? So this is y equals x. Can anyone give me an equation for this diagonal down blue line? Well, I can use slope-intercept. The side length is 6 units. So up here, this is at 6. So if I want to know what's the equation of the blue line, y equals the slope plus 6. What's the slope? The slope times x plus 6. The slope is going to go with negative, right? It's going to go down 5 every time it goes across by 6. So it's minus 5 over 6, x, and then plus 6. Okay? Because it's going down 5 steps every time it goes across by 6. The slope is the rise over the run. In this case, the rise is negative. Okay, I was happy with this system of equations because I can solve that easily. There's just a y equals x, use a substitution, and what I care about is the x coordinate. And so if I put these together, y equals x. So x is equal to minus 5 over 6 plus 5 over 6x plus 6. Now add 5/6 x to both sides. 11 over 6x is equal to 6. X is equal to 36 over 11. Perfect. It's perfect because, you see, I have now found out the x-coordinate of that intersection point. This intersection point is at 36 over 11. Now, I care about the whole thing. And this yellow thing is at 3, which is halfway. This is not 3 and 36 over 11. That's not even how you write a mixed number. But now I can find this gap, right? Because if I want to know the gap, well, 3 is 33 over 11. Let's rewrite that. 3 is 33 over 11. And so I've suddenly found out that half of this is 3 over 11. So now I'm in this world again. Now I'm in this world where I know that this part is 3 over 11. And I know that the height is 1/2. Okay? And what I was supposed to do is I was supposed to take the product of the two diagonals divided by 2. I already got the divide by 2. I already did that here. And so I just need to multiply these two numbers because I've got one full diagonal and half the other one. Multiplying these two numbers gives me that the answer is equal to 3 over 11 times 1/2, which is 3 over 22. Ooh. Okay. So that's my proposal. 3 over 22. Am I right? Am I wrong? We'll find out soon. I'm looking at this thing trying to say, would there have been a better way to do this? Honestly, here I was happy because I was like, that's a nice, easy equation. Y equals x. You made my life easy. There are probably other ways to do this where you can try to find ratios as you keep going. But let's go and see if that's the answer. Okay? 3 over 22. It is. So that's how you can do this question. And again, if you have some other ways to do these, please feel free to share. Instead, I have 8 more minutes to try to do the last question, which is really funny because there's supposed to be 30 questions for 40 minutes, and here we are trying to do the last question with 8 minutes. Whoa. It looks like our label overran a little bit. Hopefully our time won't. Okay. How many ordered triples of positive integers, A, B, C, have the greatest common factor is 2020, and the least common multiple is 2020 squared? Okay. So this is actually something that it involves some number theory. And the way that number theory works is that, first of all, if I want to know what is the GCF, greatest common factor, of something where I went and already prime factorized. Suppose I have something like 2 to the 1 times 3 to the 4 times, I'm making up random stuff, okay? 5 to the 1, and let's put a 2 to the 4 times 3 to the 7 times, no 5 to the 0. The way you GCF these two things is you say, look at this. If I want a common factor, well, the only primes I get to play with are 2 to the something times 3 to the something times 5 to the something, and the greatest power of 2 that I can use that's common is the minimum of these two. The biggest one I can use is just 1, because it's actually to the minimum of 1 and 4. And how many 3s can I take if I want the greatest common factor? Well, I can go up to the smaller of 4 and 7. And for the power of 5, I can go to the smaller of 1 and 0. So what I've just showed is the way you GCF stuff is you actually go and take the powers of the primes you've got, and you go and take the minimums of them. Okay? How about the LCM? Let's do the LCM of the same things. 2 to the 1, 3 to the 4, 5 to the 1, 2 to the 4, 3 to the 7, oops, 5 to the 0. I'm emphasizing that I'm writing to the power 0 because sometimes if you're prime factorizing, you might just not write the 5. But let's do 5 to the 0. That's the same thing, okay? Now, if I do this, what happens? What's the only thing that changes? If I want the least common multiple, well, suddenly, I want a common multiple. If I want a common multiple, they both have to be able to multiply up to it. Therefore, if I'm going to multiply up from anything which already has 4 2's, I'm going to have at least 4 2's, right? It's going to have more than 4 2's, maybe. But the least common multiple is just 4 2's. Because this guy, to be a multiple of this, you need at least 1 2, and you need at least 4 2's here. So you need at least the maximum of 1 and 4 for the number of 2's you've got there. Now, how about the number of 3's? It's max. The only thing that changes is min changes to max. Max, 1 and 0. So that's cool. Whenever I want to do GCF and LCM, effectively all you have to do is prime factorize and take minimums of powers or maximums of powers. Why did I do that? Well, because I have some information about this. Okay, so now we need to know how to prime factorize 2020. I thought that was last year. I thought this year everything's going to be at 2021. But anyway, we'll do 2020. PTSD. So 2020, how do you do this? So like prime factorize. Actually, I'm going to just already take out things. I'll show you how I prime factorize fast. Let's take out 20. 20 happens to be 2 squared times 5. Okay, that's 4 times 5. And that's 101. Oh, that's the end of my prime factorization. 101 is prime. Okay, so the prime factorization of 2020 is 2 to the 2 times 5 to the 1 times 101 to the power 1. Okay. So now what I need to know is I need to know how can I make the GCF have 2 to the 2, 5 to the 1, 101 to the 101, 101 to, no, 2 to the 2, 5 to the 1, 101 to the 1, okay? And the LCM has to be that thing squared. And that thing squared is going to be with like powers of 4, 2, and 2. Okay. Well, let's go to the next screen so I can write some stuff. So now I know with the GCF, ordered triples. Oh yeah, by the way, I have 3 numbers, okay? I have to have 3 numbers here. This is just 2 numbers, but if I have 3 numbers, the same is true. That's actually why I showed the minimums and the maximums. Because if I have just like 3 numbers, then what I do is I take the mins of all 3 exponents of the 2's. And I take the mins of all 3 of the exponents of the 3's and so on. Okay, so I have that the GCF of A, B, and C is supposed to be equal to 2 to the square, 2 to the 2 times 5 to the 1 times 101 to the 1. And I also know that the LCM of these 3 numbers is equal to, okay, ordered triples, 2 to the 4 times 5 squared times 101 squared. Okay, well now if I have this, I need to say whatever the powers of these are, the smallest. So I'm looking at this and thinking about it. So the minimums of the powers of A, B, and C, of the minimums of the powers of 2 in A, B, and C are 2, and the maximums are 4. I'm going to split the problem into being like, how many 2's are in A? How many 3's? Wait, is that what I want to do? It's like how to distribute 2's in A, B, and C, how to distribute 5's in A, B, and C, and how to distribute 101's in A, B, and C. That's what I want to say. Okay? I'm going to ask an easier problem. I'm going to say how to decide how many powers of 2 are in each of A, B, and C. We'll make that decision. And then we'll also ask a separate question, which is how to decide how many powers of 5 are in each of A, B, and C. And one last question, which is with the 101. How do you do this? With the 101. Okay, runs into my head. Almost. Oh, it's good that I got a haircut. Anyway, so it's like all of these things. And what we're going to do with this is we're going to then multiply the number of ways to do the green times the number of ways to do the yellow times the number of ways to do the purple. The reason is because I can just make my decision on how to distribute the 2's, It's like you assigned 3 different people to do the job, do different parts of the job. The green person, the yellow person, and the pink person. And they each made the decisions, and when they make the decisions, it's like now they combine together. Because if the green person said, hey, I want A to be 2 to the power 3, and B is supposed to be 2 to the power 4, and C is supposed to be 2 squared, great, green person decided how many 2's are divvied up. And the yellow person went and divvied up the 5's, and so you go and multiply. You go and say, oh wait, if A was supposed to be 2 cubed, and yellow person said, hey, give A a 5 also. Then you say, okay, so far I've got 2 cubed times 5. I'm basically showing how you're building up the prime factorization of A, B, and C with these 3 different questions. And so I need to know the 3 different answers and multiply them all together. All right, let's start with the green one. And now I see this is good because the answer to the yellow and the answer to the pink are the same. Well, how do I do this? Well, I need to say, how can I decide how much to give A, B, and C so that the smallest is 2 and the largest is 4, right? Because that's what the GCF tells me. It tells me that I need to have that the minimum of the how many 2's, let's just say the number of 2's in A, the number in B, and the number in C has to be equal to 2, and the maximum of the number of 2's in A, B, and C is equal to 4. Well, if that's the case, then one of them is going to be a 2, one of them is going to be a 4, right? So I now have I have to figure out how I want to go and disseminate all of these. I guess here, I just see that the way to do this is that you will either have things like 2, 2, 4, or you'll have 2, 3, 4, or you'll have 2, 4, 4. And I have to think about the rearrangements, right? I need to say like, okay, if I have, this is like how many, oh yeah, the way to think of this is like the number in A. The way I'm thinking of this is like, how many are in A? How many 2's are in A? How many 2's are in B? How many 2's are in C? That's actually what these 3 columns mean. All right? How many 2's are in each of them? Let's label it somehow. So this is like the number of 2's in A, B, and C. That's like how I'm thinking of this chart. But I have to do all the rearrangements. Because if I have 2, 2, 4, I could also have like 2 2's in A, 4 2's in B, and 2 2's in C. So I have these rearrangements. This thing has actually 3 rearrangements. 3 total rearrangements, right? Because I can do the 2, 2, and the 4, and I can do 2, 4, 2, and I have 4, 2, 2. This one here, I can do 6 rearrangements. That's 3 factorial. Because I have 3 different things. That's a combinatorics thing. And then over here, this 2, 4, 4 has 3 rearrangements. So 3 plus 6 plus 3, I get 12. So the answer to green is 12. Now what's the answer to yellow? And we're almost done. The answer to yellow is the same as the answer to pink. And I just need to know how many ways can I find the maximum number of 5's and the minimum number of 5's to be certain values. The minimum number of 5's in A, in B, and in C is supposed to be 1, and the maximum number of 5's is supposed to be 2. How can I do this? Well, I've got even less choices. So here it could be the number of 5's in A is 1, and then, well, it could be 1, 1, and 2, or 1, 2, and 2. Those are the only 2 ways that I could go and try to only 2 general ways that I can try to divvy up these numbers of things, numbers of powers of 5 in A, B, and C. And the number of rearrangements that each of these has is 3. 3 rearrangements. Okay? And this is also 3. So 3 plus 3 is 6. So I get 6 here. And so my answer to the whole question is going to be 12 times 6 times 6. Okay, I know that we're over time, but that's because I want to at least get the answer to this, okay? So there's 12 here. That looks like a 72. This is 12 here. This is 6 here. And this is 6 here. Now I need to go and multiply these together. 12 times 6 times 6. What is that? Well, 6 cubed is 216. So times the 2 should be 432, I think. 6 cubed is 216. No. Yeah, 432. Let's go and double check. So if I actually wanted to multiply these together, 6 and 6 and 6 is 216 times 2. That's going to be 2, 3, 432. So my guess is that the answer is this 432 over here. Okay, let's go and see if that's the right answer. Bingo! It is! Okay, so that was the hardest question on this sprint round. The hardest question on this Math Counts chapter invitational sprint round. Pretty hard. Actually, I know we're over time, but just what really happened here was this was some kind of number theory problem. And whenever you're doing GCF, LCM, that's actually about minimums and maximums of powers. And it becomes a distributing stuff game because it's a combinatorics in the end. And then it became, I have 3 different questions. Let's go and break apart how I made my A, B, and C by assigning 3 different people to decide how many 2s, how many 5s, how many 101s. After they make their decision, they come back together and you're like, here you go, assemble your numbers. And so that's actually how the whole thing came out. All right. Well, with that, we have managed to finish the chapter sprint round. We made 2 mistakes along the way, but thankfully there was everybody here helping to fix. We're going to do the target round tomorrow. And tomorrow it will be, I think, 6:30 to 7:30 Eastern Time. I'll see you all then. Happy Pi Day, everyone. Bye-bye.